And tell me now, what are the 4 questions you're supposed to ask for the data? Pardon? Is it connected? Relevant? Accurate? Enough. Is it data is enough? Very good. Is it relevant? Is it connected? Is it accurate? Is it enough to work with? Those are only 4 questions. That's it. So what are the 3 gaps in machine learning? World doesn't change, we assume, so that's a gap. Sometimes the data is not sufficient because of the data is going to be collected in the future. Third one. Okay, what costs what? So these are the 3 gaps. Of course, how do you fill this gap? By human insight. Okay, the human has a kind of lot of intuition. Okay, they can just make a lot of good guess even with a less amount of data. So through that you can just make really close the gap. So how do you feel that we have just come to the end then? Did you find this really useful? 5, 4, 3. 5 questions to the data science, 4 questions to the data, and primarily there is 3 gaps. Primarily, of course, I'm not saying that it's not covering all, but primarily there's 3 gaps.
So, as you said, there are gaps for machine learning.
Right.
So, what specific fields, how do we classify which fields that ML data science using ML algorithms? We could use data science in this specific field so that we get this much output in this specific domains, and if not, we should go for other.
Now, what you are talking about is more like best practices, right? So, I mean, which algorithm fits good for this particular domain, this industry, or this particular. It's more than the domain. It's that specific on a specific nature of the question or the problem, right? So let's say that there is something called SVM algorithm, the support vector machine, and there is a PCA, the principal component analysis. So these algorithms are fits for when you go really the more number of the features. Okay, within these 2.
I'm not from any computer background.
Okay.
I'm from electrical and electronics.
Fine.
I have my necessity of using these tools is only after data falling in my. I want to relate what is the performance of the whole system. So how could I do that more efficiently?
Yeah, there is something which you need to really need to learn about the statistics.
Yes.
So the statistics will going to help you, and the Python and the R programming, both are very powerful languages for the data science, and both have comes with a rich number of libraries. Okay. In case of Python, I believe it is now crossed to 154,000 as of today, I believe. I think last week it's 150,000 libraries. The projects have been completed in the Python, which is put it in the pip. How many of you know the pip? Right? So similarly, in case of R also, there are so many libraries. Okay, so many libraries. So it is using those libraries you can just really you can do all sort of things. Okay, that whether it is really it's good fit, it is underfit or overfit, the curve is underfit or overfit, all this kind of the checkings can be done. All kind of the stuff. It is almost answer all your questions. Now, in fact, these are very much there. Why we are doing it right now in the system is very recently only that memory became cheap, right? The RAM became cheap. And so now we are just having I remember that the least RAM which I just worked is a 64 KB. Okay, 64 KB RAM. Absolutely RAM. There is no hard disk or something like that. There is no hard disk, zero hard disk. And we have to insert the big floppy of 8-inch floppy, and then store the data and boot the system and then work on that. So when you are working on embedded programming, assembly programming, all this kind of, it's really difficult. You cannot think about that, all these languages today that like Tableau or Power BI kind of stuff, that's kind of, or maybe there's no situation for the using the Hadoop kind of stuff, because there's no big data, so it's a very limited time. But algorithms are there. But because of today that we are solving the problem is very effectively, because one is the computers are faster and the RAM is cheaper. The memories are cheaper, the processing capacities are very fast, right? As I said, there's 100 core processors are there. In phone we are getting octa-core, right? So obviously it's a pretty easy to work in the data science. You don't really need to worry about that. Required the heavy mathematics knowledge or statistics knowledge. That's what people say, but I don't say that. You don't require a mathematics or statistics knowledge, high statistics, mathematics knowledge you don't require. And most of the time you don't require. I'll just show it in something in the slide itself. Okay, this, if you feel this is really this session sounds like a worth, does it sounds like a worth? Then you please thanks to Brandon. Okay, so I brought this one is most of the stuff which has been said by him. Okay, so he's he's not in Microsoft. He's not in Microsoft right now. He's a data scientist in Facebook. Okay, I really recommend this book, Thinking Fast and Slow. Okay, especially for you, and of course everyone read this rather than going before the statistics, reading the statistics and understanding the mathematics. Okay, so just go through this. This makes more a sense to the data science. So Daniel Kahneman is actually he is a winner of the Nobel Prize in 2002. I just want to show this. I think probably Butt will cover that. I just want to keep that the crisp. He is asking some of the questions like how much that do I need in a mathematics or something like that. I'm saying that most of the data science, no, you just you sit here. This portion of the work, it just comes almost 80%, 70, 75, 80, definitely not less than 70. The majority, or 80%. So this modeling, you don't do it actually. You don't. You may use that existing models, and then existing algorithm, and then you pass some of the parameters, and then you just look for which is the best fit or not, and you train the data by putting the training data, and you infer the results, and then once you could able to predict that the accuracy level is good enough, then you go and deploy and get the feedback again from the end user, and then you just do this cycle. So this process is actually very less time. This is 80. Till this point it is 80%. So most of the time you will be doing this kind of work. So when you're not to panic about the data science means it is something like a 2 PhD, 3 PhD kind of stuff. That was the case at some point of time. But now in the data science, there's a huge, the demand is happening. So obviously, you don't require to master the entire the process. Okay. And obviously I say this one. The most of the time, today, that you do that lot of. I want to introduce the two technologies. One is called CAP technology, other one is a FAR technology. Does anyone aware of this? CAP technology? Oh. Copy and paste. And FAR technology is a find and replace. Okay? If you know that, today in the Google, you don't really require to remember everything, right? So everything is available in Google, so you can just Stack Overflow, and there are many other sites like Kaggle, KD Nuggets, and then Quora, and these kind of many sites. I mean, the Google, you just Google it, and you can just solve the problem, most of the problems. The community is larger and larger, so it's becoming so easy. Okay? And all you need to know about only the basic arithmetic. All you need to know that how to add two numbers. You don't require to know about the big mathematics. Forget about the calculus, integral calculus, differential calculus, successive differentiation, maxima, minima, topology, or analytical geometry, or polar geometry. Don't worry about that. All you need to know how to add two numbers. Do you know that? All of you? I'm sure. All of you know the two numbers. Even you don't require to know what is subtraction. Just addition is good enough. Because subtraction is nothing but addition of two negative numbers. So the subtraction is nothing but addition of the negative number, right? So similarly the multiplication. So it is nothing but addition of the multiple times of the same number. So division. So it's just, if you know very basic arithmetics, that's more sufficient, which you are already aware of that. So you don't require to know really in a great mathematics. It's all again like those mathematics also in a pretty simple.
The challenge of any data scientist is not the calculation or deriving results or analyzing the data. It's about asking the right question.
Exactly.
And what should be that question, and is there any methodology that any person, data scientist should follow to identify that question?
Yeah, that's a question which I was talking about. Now the 5 questions, which is false, the data science questions, and the 4 questions which you asked about the data preparation. Okay, so this is the one, and very important. If you just look at the CRISP, okay, the cross industry, the standard process. If you just look at that, it very clearly says that the business understanding, and there's one more key component, is the data understanding. So the business understanding is a key. That's where it starts. It's not about the mathematics and the statistics. Even I said that it's an interdisciplinary field, and one of the Venn diagrams, one is a math science, the other one is a computer science. The another one is basically domain, right? The business. So
Coming from top-down mode understanding the data. From domain-specific business understanding, then data understanding, then
I don't know what is a top-down in this case. I say it is like more like a spiral kind of thing. You need to approach in all directions. Of course, definitely the business understanding. Of course, if you just think in a very technical perspective, you need to address from the top down. Okay, but in the object-oriented programming perspective, you say that the bottom-up is something is different. You just create a small object and then go like that, right? If you're just solving in a waterfall model, so like more like a top-down approach. But there is something called spiral. Okay, so using that kind of model can be, I can just say that it's not necessarily a top-down. You can start from anywhere, but very key is business, domain. Not your mathematics, statistics, or your data science, and many people think, oh, I'm not a programmer. First of all, here you don't write in any explicit programming. Okay, so there is 2 languages. The best language is a Python and the R. Probably in a Python you write 8 to 10 lines of code, which is, if you write it in the same thing, you can achieve 2 to 3 lines code in R. But same thing, if you want to write it in C, you may end up writing like maybe 100 lines or 150 lines or maybe 200 or 300 lines of code just to translate, get what you get it in the 2 lines of code. The one is basically the data structures which they defined is the key. In case of R programming, the data structure, the basic data structure is a vector. So that is the key success for that. I mean, they designed that language for a very specific purpose of making a query, asking a complex statistical questions, analytical questions. That makes sense? Yeah. Any questions?
I got what you said. Obviously, we need business domain knowledge to ask the right question. But yet, even though you have the business domain, sometimes let's say if I want to know if I should launch a new product. Okay, my sales are good, everything is good, but I should know whether I should launch a new product to improve my sales further. I mean, how should I get this kind of question as a data scientist? I mean, is this a relevant question also?
Yeah. See, the one thing is it not, again, like we are in the data scientist. The data scientist is the ultimate position. If you just really, you want to reach the top chief data scientist, perhaps you have to really ask that question. You really need in this case, I'm not saying that you have been excused for not understanding the mathematics or the basic mathematics is sufficient. I don't say that. You really need a good mathematics, good statistical knowledge. But definitely more than this is your domain, the business knowledge. When you know that business, it is a pretty natural that you'll ask your best questions. Am I right? I mean, if you just know that just you having the tools will not answer. But if you have this, I think this Python language or maybe the algorithms, the programming algorithm as a computer, whatever I just consider as a tool. What is the real story is basically domain, the business. So unless until you understand that business, you cannot frame the question. That's what I'm telling again. So the key is not the algorithm or programming knowledge or something like that. It is the key is the data science. If you just, it is again like the very important thing is you don't go in case of in academically what we will do, pick one data set, maybe that you go to US government data set websites. If you just go there and you will find lakhs of at least a few 100,000 data sets are available. You pick that data set and you query. That is only it is an academic kind of thing. You are practicing it. Right? So you may end up like, okay, I have this data and I'm going to ask the question on that data. Whether your first thing is whether your target data is there or not. So based on that you will ask. But it is not that way it goes in the real time. In the real world business, you should know the business, and in the business you should know that. It should drive from the business. That what question you're supposed to ask. What question you're supposed to ask. So even if the data is not there, you have to collect the data. So there is a data collection. In the CRISP DM you saw that one, right? There is a data collection. One is the data requirement, data collection, data preparation. The data understanding and the data preparation. So this is a required stuff based on the business understanding. What you just talked about analytical approach, how I am going to approach analytically, but again it starts from the business understanding, right? So business understanding is the key. The more you understand the business, you can ask the relevant question, not just because you have some knowledge of model or something. Maybe it just helps you. So it should not be the drive should not be that I have data on this, what kind of questions I ask. That is not the stuff. You should ask other way around. This is the business is driving this question, so what to answer. So maybe I just talk about the desirability and feasibility and then viability, but maybe some other time. Okay, and yeah, please.
traditional VR analytic solutions that are available to the businesses, they are driven by the requirements of the practice head or a department head or a CXO. Okay?
Right.
But in case of data science solutions, who drive these data science solutions? Like, is it data
Earlier, there was not so many roles have been not discovered in the data science. But data science is not old in terms of the field perspective. The artificial intelligence is as old as of 1960s or 50s, we can say, the start point. The machine learning and all started in somewhere in the 90s, 80s, 85, in the late 80s and the 90s. And the deep learning has been started in somewhere in the 2010. In the last 10 years, maybe around 2008, 9 perhaps. You will be not that as a data scientist, it is not that we are just need to prepare ourselves everyone to the ultimately the chief data scientist position or something like that. Now there are a lot of role. Perhaps now something called feature engineering. Okay? There's a data engineering, the data product developer. So mostly you will be working you are not even just touching on the model part. Even before getting into the model part, there's a major portion. I said no, the 80% of time you will be working on that. That itself is having so many roles. So of course, if you just a data scientist should have a really data scientist should have the all kind of knowledge of the entire the process, but not everyone need to have it, right? So that is not going to be happen that everyone will become the chief data scientist of the organization. So definitely that will not the case. You will make they call it as now they are having a trouble in this industry is with the kind of naming the designations or role or title for that to make a very meaningful things. So that's why we are using this data science. So that's why I say it's a cliche kind of stuff. They've been very overused or maybe that heavily used it. Thank you.